Um, okay, so I haven't got anything to say this month because I wasn't even sure we were having a meeting next month, but apparently, according to the poll, yes, we are. I expect it will just be an informal, chatty one rather than a specific speaker, but we'll see if anything comes up. Right, so now I will pass over to Gerph. Or better unmute yourself and to tell us all about building RISC OS online. Take it away.
Good evening. Right, first thing I should do is I should share my screen. So, good evening. I don't know how this talk's going to go over, but I'm hoping it'll be interesting and maybe a little bit surprising. So let's go. There's a lot of technologies and features that I'll talk about, and I'll call them out as I come to them. Some of what I'm talking about may not be familiar to RISC OS users. They may be much more common to users outside of RISC OS. If there's something you don't understand and you feel needs clarifications, please ask a question in the chat if you can. Somebody else might be able to answer, or I may be able to come back to it immediately. At the end of a section, I'm going to have a short break so people can ask questions on that section. This should give us a chance to talk about what I've talked about in that topic without getting too far ahead and people getting lost. At the end of the talk, these slides and a bunch of links to resources will all be made available. There are 5 sections to this talk. I'm going to do a little bit of background. I'm going to discuss what JFPatch-as-a-service or build.riscos online is and what you can do with it. I will be referring to it as JFPatch-as-a-service because I only decided to change the name earlier in the week, but you'll know what I mean. I'll do a very light dive into how the service works, look at what's the system that powers it underneath, and then finally I'll give you some conclusions. At the end of the talk, I'll take more questions on the subjects that have been covered here for as long as people want to stick around and I can stay awake. So I'll start with the background. We're going to jump back about 1.5 years from today, which will set the scene. You might know me as Justin Fletcher or Gerph. I changed my name a few years ago, but I use Gerph where I want some continuity. I'm a RISC OS architect, and in my day job, I'm a software engineer. I've worked with all of RISC OS from chip initialization through to applications and development tools. I'm pretty confident that I know it better than most people, even after 15 years away. Plus, as I'll talk about, I've worked on many of the RISC OS interfaces more recently, which makes them much more familiar. If you want to know more about my past, the RISC OS Rambles on my website talks about it in much more detail. So, why did I start doing RISC OS things again? Well, about 1.5 years ago, I began to understand that I was very unhappy. I didn't have anything that focused me. I didn't work on RISC OS things because when I do, I get angry and I get upset. And then I'm useless for days. So I stayed away. I've tried to deal with that, but things still set me off. Even little things can be a problem for me. I wrote the Rambles to try and be a cathartic release, but it wasn't completely successful. So I still stayed away from the RISC OS world. I have regular counseling. And I believe it's been working because I realized about 1.5 years ago that there was something I could do. I realized that I enjoy working with RISC OS, but I don't enjoy interacting with the RISC OS community. I'm not offending anybody here, I hope, because that's what's debilitating for me personally. And stopping myself from doing things with RISC OS because I understood how badly it affected me has been a way of coping. But I realized that I can do RISC OS things for myself and not care what anybody else thinks or whether anybody sees them, and just do it because I enjoy it. And well, that was just amazing to me. I had the light bulb moment of, I can do these things. And that's why I'm doing this talk, because I'm really proud of that realization. I can do things because I enjoy them and not because I feel I have to prove things to people. And that's what this talk is. It's my way of saying, this is what most nights makes me laugh when I go to bed, chuckling, this is effing nuts. Look how cute that is. JFPatch-as-a-service is the bit I've made available to the world, but the rest, we'll get to that. So I decided I would dust off some old source code and I would try to build some things, but there's some problems with that. Firstly, RISC OS development tools are a bit poor. They only run on RISC OS, and I don't have a RISC OS system. Not only that, but if you've worked with DDT, the debugger, you'll know how much like Russian roulette that really is. And if you see the insides of it, you'll know why it's like that. The next issue with RISC OS development is that projects on RISC OS have awful testing in my experience, and that includes my own. Ad hoc testing is the way that most things are done, and the mantra of, it's compiled, well, ship it, seems to apply. Maybe that's not true for developers these days, but that's how it was. And I wanted to be able to address that if I was going to do anything of any merit. The final issue is that RISC OS itself is not a good system for running tests on. It's cooperative and single tasking, and generally the system under test, the thing you're trying to run, doesn't cooperate. It'll hang, it'll crash, and it'll leak memory like it's going out of style. And on RISC OS, that means rebooting. Plus, there's no isolation, so even if it doesn't look like the system's broken, it might have corrupted something important when you were testing. And I needed to do something about that. So we've understood some of the problems. Let's see how the real world deals with these things. These are a few of the things that the real world we expect to have, and which I'm going to have a look at. The source control, compiling code for RISC OS from other systems, controlling your development environment, automated testing, and having fleets of machines to do things faster. Let's have a look at how I addressed each of these. Firstly, I have my own source code in CVS for many years. And about 2016, I moved everything, even my ancient RISC OS projects, into Git. I have a large number of Python and Perl projects managed in Git as well. And it's so much easier to work with than CVS, even for just one little script that you want to tinker with. You can create a repository for it. Git is a source control system that's intended for large-scale distributed use. But it works really well for even single user working with a single file. It doesn't need a server, but if you want to share your code, that's one way you can do it. GitHub is one of the best known systems for storing repositories, which people will also almost certainly have heard of. At the time, GitHub wasn't friendly to private projects. And even still, I didn't want my projects going off-site. So I chose to use GitLab. It's installed on my server, and it's pretty great, and it's free. So GitLab is the tech I use for source control, and I was amused, but not at all surprised, that ROUGOL selected GitLab as their server system a few years ago. So I had a way of storing and managing source code, and I wanted to be able to compile and assemble things if I was going to work on them. That's all well and good, being able to build RISC OS components for testing on macOS and stubbing libraries, but I wanted to be able to build things that will actually run on RISC OS. Back in 2005, I had cross-compiling working for RISC OS with the Norcroft tools. And most of the last version of RISC OS that I worked on was completely built on Linux. However, that was all for 32-bit Linux and Windows. So I ported the toolchain to work in 64-bit compilers, so I could run it on macOS and Linux in modern systems. It wasn't actually simple, and I still see bugs now and then. The authors loved their bit fields and packing structures into different types. But with a little bit of work, the toolchain was made to compile RISC OS components on macOS. All the cross-compiling tools, as you can see here, have the prefix RISC OS hyphen to make it easier to distinguish them. You can use RISC OS AMU, RISC OS OBJASM, RISC OS link, in this, as you can see in this example. I needed to test the C compiler because I didn't know it was going to work, with some nice example code to see that it fared well. I had a lot of my own code, but using random stuff from other people to throw at the compiler highlights problems that you wouldn't otherwise find. So I knocked together a small library that downloaded all the code from the Rosetta Code website and tested it with that. If you don't know Rosetta Code, it's a website containing different solutions to different problems in many different programming languages. And having downloaded all the programs, I ran them through the compiler to see whether it crashed or not. And then I fixed the bugs. I have the tools for building things, and I have headers and libraries I can link against, but I needed to get them to my machine. Traditionally, you would download and install a package that gave you the build tools. You get a zip archive off a website, and then you just go and install it. And then you use them until you needed to upgrade. However, in modern development, these tools and libraries change rapidly. And even if they don't, you want to be able to have control over what went into building your latest product. This is usually managed through a software repository that holds those components that you might want, your toolchain, your libraries, your documentation, and even full releases. These can be stored in the repository and retrieved in managed ways. This is to ensure that what you're doing is entirely reproducible, because everything you went into it is known and can be used again. I chose to use Artifactory. It's not great. It's not terrible. It does the job. It's just a web server that has a bunch of APIs on it. And it's free. And I created some small scripts that let me push and pull my RISC OS components in a structured way. Sometimes I don't want to download the toolchain and set up binaries. I just want to compile some code. Normally, you would just install the toolchain and the libraries on the system, as I described, and then you'd be there when you needed them. You can do that, but modern systems have been taking advantage of containers. If you've not come across containers before, I'll try to explain what they are in a few sentences. Containers are a way of bundling all the resources you need into a single container. It contains only those things that you actually need, though. Docker allows this to be done within Linux systems by packaging just the little bits of the OS and the tool that you need, and then allowing you to run it in isolation. If you think that's a little bit like how RISC OS applications work, if they include all the modules it wanted, it's a bit like that, but it's much more. If the application contains the bits of the OS and the boot or system resources, that's closer to what a Docker container is. And that's the technology that's being used in this example. It bundles the RISC OS development tools into a Docker container and lets me build my source with those tools. This command line here, docker run, is then tacked onto the end of it. It has the RISC OS AMU. This then goes and actually does the build inside the container. I haven't installed anything other than Docker. It goes and downloads the necessary container and the tools within it. In this example, I'm building one of my old modules using the new toolchain. The next feature of modern development on my list was automated testing. This is very closely associated with the process of continuous integration, and the terms are often used interchangeably. The distinction to draw here is between ad hoc testing, where you test what you think is going to be a problem by hand, and automated testing, where you define the tests which you run automatically. In ad hoc testing, you essentially sign off that you think it's good enough. In automated testing, your tests tell you whether it's good enough. Because tests are automatically run, you find out quickly that things are broken and you don't introduce earlier bugs, assuming that you've written the tests for them. Specifically, that's feature and regression testing. There are other types of tests that can be run automatically, and you can write your test to do whatever you want. The GitLab source control system has a test system built into it. This lets you run whatever tests you need to when a change is pushed to the server. The test can be triggered. In my case, these tests will download the toolchain and the environment from Artifactory, build the code, and then push the built result back up to Artifactory if it was successful. If it wasn't successful, I get an email and the website reports the build log. This example, assuming you can see it, it's a little bit small, I realize, is showing the build of the JFPatch tool. Down here, you might just be able to see that I'm running basic tokenize to tokenize the source files, so I get built results out of it. Here we're downloading things from the Artifactory system, and we're setting up the environment based on what we've got from the Git repository. If I'm building, say, a RISC OS module, it has been normal to write all the code in little components that you can test out separately before you bundle them into the scary module environment. For a lot of code, you can test those components without needing the rest of the system. And for a lot of code, you can do that on non-RISC OS systems. When I was doing the RISC OS select work, things like the window manager extensions were largely tested on Windows. Windows being tested on Windows, which made it a lot easier because I could just use it in my development environment. If you're just managing data structures, you can do that a lot more easily because you don't need a RISC OS system to check that things work, for example. So in those cases, you can make your code compile and test on a different platform. That's one way of doing things, and it's very effective. In fact, just last month, Jason Tribeck was explaining exactly that process for his unit testing with a sound system. But really, I want to run things on RISC OS because that's the environment that the modules will run in, and it's a bit different. And you'll want to communicate with other parts of the system. In particular, modules run in SVC mode, the mode with the highest privilege and therefore the greatest power to make it a bad day for you. We'll come to how you do that later. My final feature of modern development was to have a fleet of machines available to do your bidding, whether it be testing or processing. And maybe you don't need that. But if you want to run a few thousand tests at a time, you can save time by spreading them across multiple machines. JFPatch-as-a-service isn't quite that, but it's a step along the way. So, before I move on to talk about JFPatch-as-a-service itself, let's see if there are any questions. People want to unmute themselves. Any questions in the chat?
How are you writing the tests? Are you using JUnit or what's the format for that?
So the tests I'm writing, I actually have my own system that controls them. I wrote a special tool that can go and invoke tools to manage them. And largely that's because I didn't want to start pulling in lots of more complicated things. But we do output JUnit XML so that the test systems can process those results. I haven't used JUnit specifically. Putting Java on the systems is a little more heavyweight than I wanted to do.
So a question about testing. So when you talk about testing, you probably are talking here about unit testing.
I'm talking about unit and system testing. So Jason's example that he was doing was heavily into unit testing. And I have got some stuff that does unit testing, but largely I'm focusing on the integration and system testing is what I'm actually focusing on for a lot of these things.
Okay, so I'm very interested how you're testing, multitasking application.
That's a very interesting question, and it's not one that I've actually attacked yet. And largely the reason for that is because I don't have a multitasking environment to use just yet. However, that's not to say that you can't do that. I will, however, come to that in section 3. So we'll talk a little bit more about what you can do there. If you would like to talk to me later about how we could attack those sorts of things, I would be interested in ideas. I have my own, but there's a lot of things you can do.
Oh, absolutely. No worries. I was mostly thinking that would match your environment to start to look at QEMU and spin up instances of RISC OS, and then obviously using some way of reproducing the human interaction in there.
Those are some very interesting things. I'm not jumping ahead too far, but there is a Docker Hub repository. If you look in the user Gerph, you'll find that there is a repository that spins up a RPCMU with RISC OS 5 and 3.7 available at the moment. So that is currently available for people. They can use that if they want. It's just using the images that are on the early start from Maritain. So that is another different solution to what I'm talking about here, but I learned about that and went, yeah, let's give that a whirl. Largely it's because my friend Chris mentioned it one day and I went, I've got a lunchtime, I'll have a play with that. So you can have a look at it if you like. There's also a GitHub repository that contains all the Docker files for that if you're interested.
Definitely have a look. Thank you very much.
No problem. Okay, any other questions?
Can I ask one?
Yep.
The versions of the development tools that you were using, the RISC OS-link and so on, are they running natively on the x86 platforms, or are they, or x64 platforms, or are they running via QEMU?
They are running natively, and therefore they run at full speed, which means that things like the kernel compiles in about half a second or something. And the kernel is one of the smaller components that you can build. Yeah.
Expect an email about that. I'm intrigued.
So I don't necessarily have, I don't have the rights to that, to distribute those. That may come down to yourself and others to discuss. However, my tools that I've ported are very old. They're based on tools I got back in 2003, 2004-ish. So
that's all.
I will be happy to go and pass on the changes and the necessary bits. I suspect that ROUGOL have already done equivalent things. If they haven't, then I would be surprised. Anything further?
I remember that those original, especially the Norcroft, was developed to be executable on different platforms. As a matter of fact, I think Acorn also distributed it on RISC IX, right?
I believe so. The people they licensed the compiler from produced versions for many different platforms, and in the source code you can see large amounts of references to other platform systems.
But this is really, blurry memory, even MS-DOS, I think.
MS-DOS things, there were references to VMS in there. And obviously they also had a version that went for Brazil, and there were still references to Brazil in the version I had.
That's very cool. And by your experience, knowledge, and everything, how would you compare the tools, your tool chain, with what we got on RISC OS in terms of supported CPUs and all this stuff?
So the versions I've got are Norcroft from 2000, so 518 to 534, if you remember those versions of the Norcroft C compiler. That's the level it's at. I don't have any later sources. And the version, I don't have versions that have been produced by ROUGOL recently, but the announcements that I've seen look like they've produced huge amounts of things. That said, I mean, it produces 32-bit code, and just like the original version did. I am not a C compiler person. I am not a toolchain person, although I will work with them. This is not my specialty, and quite honestly, I just made them work. So if somebody else wanted to either take over what I have or to just merge that into the main tool chain. Let's see what they can do. I don't have the time, Druck. I have section 4 is what I'm spending my time on at the moment. I will come to that. This is why I say I'm actually very happy if anybody wants to take over these things to do so, because I have the interest but not the time. I focus on what keeps me happy is essentially what I'm doing. And the compiler, although it's necessary for a lot of what I'm doing, it is just a tool. It is just a tool to me. Okay, that was a little longer than I was expecting. Does anybody have anything else, or shall we move on to the, what do we got next? JFPatch-as-a-service itself. Okay. Let me just find where I'm up to. Let's talk about JFPatch-as-a-service. We're spinning forward about a year now, and I'll cover the missing time a little bit later. In early March this year, David Thomas challenged me to make some of the things I've been doing public. I was still a little bit nervous about that and really wasn't comfortable making that kind of announcement. But the idea of doing something for April the 1st, which wasn't actually an April Fool, was rather appealing. I genuinely expected the response to be meh, but that wasn't the point. The whole point of the work I was doing was to be enjoyable, and I like solving problems, particularly when those problems are strange. It had been floating around my head for a while to do something like it, but it hadn't really solidified until then. Running an on-demand RISC OS build process on a cloud system as a service is probably unique. And I've been away and I don't pay attention to the comings and goings, as I've said. So it may be completely passé, but I like the idea. And I like the idea of surprising people with something they didn't expect. JFPatch, it's an assembler I wrote when I was at school, well, preprocessor. And that was something like 25 years ago. I learned assembler by reading other people's code and then patching it to do different things. Largely, that was by writing a little basic program that loaded the code, assembled some replacements, and then saved it again. And that's really tedious. I wanted a shorthand for doing that without the boilerplate. So I created a preprocessor that built basic programs from a patch file. And I knew that I shouldn't pollute the namespace, so the tool got prefixed by my initials. And it's actually not that clever, but it can construct a lot of the boilerplate that goes into writing modules. If you want to write a module that registers itself with a few vectors, you can do that in a couple of lines of code. It even goes so far as to let you register a whole file system with just some simple definitions in the header. So what's the service? The service is a front end that lets you upload JFPatch code, builds it on a cloud server, and then returns the result to you. I wanted it to be a tool that could be used a little bit like Matt Godbolt's Compiler Explorer. If you've not seen Compiler Explorer, it's a website that lets you enter some code and examine what the compiler makes of it, what instructions it compiles and how they're ordered. It does a different thing to JFPatch-as-a-service, and my work isn't anywhere near as polished and professional as that. But that's where the idea came from. Matt's an ex-RISC OS user, and I look up to him greatly. He's done some amazing things. But what can the service do? It can build any JFPatch code that you throw at it. And now that the module header is 32-bit safe, it can work on modern systems as well. But the service can also build C code and Pascal. And it can run basic programs and build OBJASM code. And if you give it a zip archive with an AMU file in it, it would invoke and return the binary it thought was produced by it. You can try this out on the real site if you'd like, and here's what you'd see. The editor, this bit here, lets you enter the code you want to build, and your code can then be sent to the server for building. The build output appears here, and any output files can be downloaded. This is just a very small C file that I've built. I believe this example is one of the examples that I've now included in the drop down. If you click on this, it'll give you an example C hello world program. This is a very simple Perl program. There's no returned binary from this. Can't download anything because it just printed out a message, printed out hello world. And you can see that it did that. It's really not that exciting. And this is a BBC Basic program that also does very little. And as you can see, it did indeed print out hello world and what version of Basic it was doing, which is what the report produces if you don't have any errors. And actually, the service could do this from April 1st. I'd hoped that somebody would come along and play with it and find out that it did more than just building JFPatch. I know I would have done. It's not hidden. The HTML source on the website says explicitly it supports these things and describes what languages are recognized. But nobody came to talk to me about it, and that Easter egg remained hidden. I announced it just last week, but it was hidden at the time. In the time since then, I've converted a few other RISC OS tools to be built automatically by the service. And they're on GitHub with the label RISC OS CI. Some of the tools were very simple to make work. Rick Murray's error cancel, for example, was just a matter of adding the right build commands to the repository. Others were a little bit more involved. Julie Stamp's CObey, I had to tweak the code, and that's because, as I've just discussed, I'm using a very old compiler that doesn't actually support anything but C89. Running the build automatically on submitting the code is a great way of checking that it still works. It's part of that CI, continuous integration that I talked about. Presumably, the user builds it themselves, and it never hurts to have an automated system check that that really is the case. It's also possible to do releases of the code automatically in GitHub. So you can actually get distributable archives out of a build just by pushing the code. If you look at the ddutils.jf module that I've got linked there, you'll see that there are releases linked on the right of the page. Those were automatically created after I pushed the code. You just have to click a button to approve that they are correct. How do you use it? Well, the service can be used in one of three ways: through the web interface, as you've just seen, or by using the API. The service isn't really a service unless it can be used programmatically. And there are two APIs for accessing the service. There's a JSON HTTP API and a WebSockets API. The JSON API is more limited because basically you just post your code to it and then you get back a response. It's also got a timeout of about a minute, which is not long enough for many jobs. The WebSockets API is an interactive stream. If you're not familiar with WebSockets, then that's not especially surprising. They've been around since 2010, but unless you've been working on heavily interactive websites, you wouldn't encounter them. Unlike regular HTTP request response protocol, WebSockets are bidirectional. So you can send messages to the other end and you can receive them back. Packets are always delivered in order and always delivered completely. Their content is application defined, so once you've established the connection, you can send what you like. And the service uses commands in JSON over WebSockets to request that the server do the builds and to get the responses back from it. How do you use the JSON API? Well, you can use any URL library you like. The URL fetchers on RISC OS would work just as well. But you probably wouldn't need to invoke a cloud-based RISC OS client from RISC OS. But you could. And of course, you can pass JSON responses with any JSON library you'd like. This is the sort of request and response that you get. There's a request that sends a source file, and then there's a response that says, I've got some data. This is the file type, which is, I think, the application, the module file type. You've got the messages from the build process, and the messages from the compiler itself, which was JFPatch in this case. The WebSocket system, however, is a little bit harder to work with. You definitely need a client to work with. Fortunately, in the JFPatch examples repository that I supplied with the release on April 1st, there's a Python client that can use a package which does all the work for you. This is an example of using the WS client to build the same code. As you can see, it's got the same sort of information present in it. It's just tagged with different messages on it. However, that's not always a suitable solution. It means you have to install Python and some packages, and you have to have a system that can run that in the first place. And for those cases, I created something called ROUGOL client. Very catchy name. The ROUGOL client tool is a little tool that's able to take a file and give it to the service over the WebSocket interface. And then it reports the output as it's produced by the build process. And finally, it saves the output to a known location. Basically, you give it the file and it gives you back a binary. But it also shows you what's happened as it went along. And it's easy to make work in a build pipeline. The GitHub project for the ROUGOL client itself builds a Linux version of the tool, and then it uses its own tool to submit its own code to the service. So we get a RISC OS build of the client out of there as well. Why would you want to run it from RISC OS? I don't know, but for completeness, it tells me that if it's a tool for RISC OS, it should probably work on RISC OS. And more specifically, I can't completely repress the feeling that people in the RISC OS world will reject anything that isn't for RISC OS as irrelevant. So I have to make it work on RISC OS too. I used a couple of libraries to do this, a JSON parser and a WebSockets library. And the JSON library was actually written by a guy called David Gamble, who's a friend who also used to do RISC OS things, although I didn't discover that until after I'd finished using it. And the repository has an example of producing releases from an automated build, as well as building RISC OS code from a non-RISC OS code base. It uses sed to fix incompatible code. It is not a good example. So how does the service know what to do? Well, for simple files, it spots the language from its format. So if, for example, it's got basic tokens in it, then it's a basic file. And if it's got C comments in it, then it's a C file. It's really quite poor. But it works on pretty much anything but very simple cases. And if you give it a zip archive, it can work out what those files are that it contains. It can pick out the ones that it understands. If there's a make file in the archive that it recognizes, it'll invoke AMU on it. If it's a JFPatch file, it'll go and run that file, and that allows you to patch other files. Hoping the service guesses right isn't ideal, however. So there's more control available. If the zip archive contains a .robuild.yaml file, this is used to control how the build runs. YAML stands for yet another markup language. It's nicer to work with than JSON, so long as you avoid the many crazy cases it has. It's pretty nutty in extremis, but it's quite readable. Although I say the file's called .robuild.yaml, on RISC OS, that would be /robuild/yaml. And it might have a file type of F74, which I registered recently. In this example, from the ROUGOL client itself, we set a single environment variable. We don't actually need it. I'm just using it as a way of showing that we can set environment variables. And we give it some commands to run. These are just RISC OS CLI commands, so you can do a whole lot more if you wanted to. Build all is an obey file, which builds the libraries and then uses them to build the tool. And finally, we copy to the clipboard the content that we built. That's how the service communicates the binary that was built back to the user. There is fuller documentation of what the file format is on the JFPatch-as-a-service website. So before I move on to talk about how the service works, let's see if there are any questions on this front end.
Not a question, just you beaten me on the time. I was working on a ROUGOL client that uses the curl library and JSON.c for the parsing.
Right. Well, I'm all in favor of people writing the same thing in different ways. It means that people can do fun things. It also means that when I write something that's not very good, people can use good ones instead. Yeah.
What's funny, you were describing it, I was like, okay, just a touch too late. But yeah, I still don't have the UI component, but it works on RISC OS, so it's still CLI-based.
UI is always good.
I know.
I have no UI stuff at all.
I know. Unfortunately, it's been a long time I've worked on Linux kernel and all this stuff, so I don't touch UIs a lot. But yeah, so thank you.
No problem. It is a remote development environment. It can be a remote development environment. Yes, Andrew. So Andrew's question, sorry, was, although it's called Patch-as-a-service, is it a remote development environment? Yes, it can be. I don't think it's especially interactive. What would be really cool, and this is not usurping anything else, but what would be really cool would be if somebody could put together something that gives you a proper editing environment with multiple files, and you could edit the files and you just say go, and it goes off and does that for you with the service, or even builds it in the background for you. Now, that isn't really that much more difficult than what's there. If you know HTML, if you've got better skills at JavaScript than I have. To be clear, the JavaScript that I've written on the website is all like original style JavaScript. There is no frameworks and React and other nastiness in there, in there. But people could build that stuff if they have the skills, which I could have, but really it's not my area. It would be lovely if somebody could do that sort of thing. Yeah. There's also the possibility that you could do this attached to your editor. If you're clever enough, you have it, you save from your editor and it goes off and does it elsewhere from Eclipse or from IntelliJ or whatever other non-RISC OS editor you're using. Obviously, if you're on RISC OS, you just build it direct. You don't need to worry about that. But yeah, you could do that.
Right. I'm just amazed at how much it's come on and since you first introduced it to me.
The amusing thing is a lot of the functionality was there from day one.
So I gather. You swine, you hit it.
Well, I like to make things that are interesting and give people a bit of a challenge.
Mind is what you like to do.
It's also nice because it meant that, look, it's out there, I can use it. And I have talked to a few people about it to see if they were interested in these things, but nobody wanted to really put time in, and that's fine because I didn't advertise it as that kind of tool. So yeah, I did really well at hiding it, I suppose. Right. So as I say, it has a bunch of the compilers and toolchain on there. It doesn't have Python on there. And the reason it doesn't have Python on there is because I haven't got Python to work yet. And I might talk more about that after in the questions at the end if anybody's interested. I'm having difficulty with it. So again, also any help that can be offered with that would be good from anybody else. Yeah, I think we might have Chris here as well if you want to talk to him later as well. Okay, any other questions? Nope. Right, we will move on. How the service works. I've talked a little bit about what the service offers and how you drive it. So now I'm going to talk about how it achieves that from the back end. What's the service made of? So the infrastructure runs on Amazon Web Services on their virtual machines. It has a load balancer and a small server that runs constantly. It could scale up, but I've set it not to do so. The infrastructure costs me about $35 a month at the moment, which is about $30 a month too much. But I've not got around to streamlining it. It's another frustration at the moment. The static site is built with a tool called HSC and uses custom coloring modes for ARM, BASIC, and JFPatch. The new coloring modes were open sourced a while back, and you'll find them on GitHub. The backend is 2 Python Flask applications. Flask is a module that allows you to build web services very quickly. It has one service for WebSockets and one service for JSON. And they accept requests for builds, dispatch them to RISC OS, and then provide a conduit for the output and the throwback. The backend service uses a Python module that handles RISC OS extension data from zip files. I open sourced that a little while back, and you'll find it on GitHub. The tool that runs is JFPatch itself, or any of the other compiler tools. JFPatch was actually the easiest thing to change for this environment. It just needed a thing to pass back the binary that it was built, because usually it would just dump it in the file system. Within the service, there's a new option to copy the binary to the clipboard. And the backend code can then return the built binary to the user. JFPatch itself is written in BASIC, which is tedious to work with on non-RISC OS systems. So all the source code is stored in text form and tokenized using a tool that I wrote to tokenize it. You saw an example of that in the build that I did earlier. So this is the structure of the system. The user accesses it through the browser or through an API or the tool. And that gets directed by AWS to the backend servers. The servers decide what to do, and then they call down through the container to RISC OS. RISC OS runs the build with JFPatch or whatever, and then the results come back up here through HTTP service. And it's also worth noting that these are all using the native compilation tools. They're not using the cross-compilation tools. I haven't made the cross-compilation tools available to the machine because it wasn't necessary for this purpose. And this diagram is on the JFPatch-as-a-service site. So let's have a look at what goes on below that. There's actually 3 different ways that the service system can be invoked. There's the JSON server and the WebSocket server. And there's also a CLI tool. The CLI tool is actually only used for debugging, so it never gets used by the service itself, but it exists so that it's possible to test the process without having the JSON or WebSockets APIs get in the way for me. And when you use the CLI tool, it has to go and process all the arguments that you'd usually get given by those different APIs. This produces a build object that knows how to run things. There's a streaming version of this build object, which descends from the same object in Python. And the difference is that the streaming version communicates the process and the results through a result object, which can communicate back to the WebSockets interface. And once the build process is complete, we report it back to the CLI or the service with an appropriate final result. Let's have a look at what happens inside this build process here. As we saw from the last slide, we create a result object that holds information. Even for the non-streaming case, we have the object, and it holds information such as the output from the build, as in the text that was written out, the file types that were generated, the data, any throwback that was generated, and any other problems that it encountered. The row source module decides what type of file we've been given. It uses some truly terrible heuristics to do this, like, is there an all caps print in the file? Or is there a hash include in the file? This only applies to single files. Zip files are easier to recognize, and we can extract those. We use a RISC OS zip library that I mentioned earlier to extract the files from the archive. If they've got RISC OS types in them, we use them. If they haven't got RISC OS types, then we try to infer what type it's got. All of the files are stored in standard RISC OS format on Unix. So that means using $XXX for the file types in the file name. And whether it's a single file or many from a zip archive, the result gets written to a temporary directory. The row build module looks at the files that were extracted and decides what type of build it is. It constructs a RISC OS command that can be used to perform the build. If we saw a make file, we use a small module that determines what the linkable targets are within it. The linkable targets will be returned to the user implicitly as artifacts. If we extracted the row build YAML file, we pass the YAML file to give the commands and the parameters for the build. I avoid some of the problems with YAML by not supporting them. I have my own YAML parser that I wrote for this purpose, and that's open source as well. So at this point, we know what the build is going to look like. So we need to create a HTTP server so that we can receive throwback and clipboard from JFPatch or whatever we run. The Pyro server module does this. It sets up 2 different servers for that data to be passed back to us. In the RISC OS environment, I've got a special build of DDE utils that sends throwback via HTTP, which is then picked up. And I've got a version that receives the clipboard data from the clipboard holder. If those HTTP servers are called, they'll feed the data back to this result object so that we can return it to the user. And finally, we're ready to run things. So there's a Docker module which constructs Docker command lines, which include the routing of the HTTP ports, so we've got network that works properly, and sets up the commands to run RISC OS. There's a streamed input module, which handles streaming the data that comes out of the standard out, so that it can be returned back to the streaming interface. And finally, there's a Pyro module that builds commands that run the RISC OS we use. So there's 3 different command line sequences getting built up in this process, just so that we can run RISC OS in a safe way and isolated way on the Linux server, and then get the results back to the user. There's commands we run to get RISC OS running, to get the build running, sorry. There's the command to run RISC OS itself, and then there's commands to run Docker. It'd be nice if someone were to ask this question, but it's probably obvious from what I've been saying and the public documentation that it's running RISC OS on a Linux system. And I'll move on, before I move on to talk about how that works, let's see if we've got any questions on the backend service. No questions?
I'm just looking forward to being able to go back and rewatch all of this on YouTube so I can process it in, because there's so much content. And
I appreciate that. I did, whilst I was doing my read-throughs of this, I was also quite aware of there being a lot of content, but I didn't want to just dumb it down and simplify it, because I thought people have got the ability to watch it afterwards. But I do appreciate that makes it a lot harder to know what to ask and the like. That's just fine.
No, actually, I got a very, I'm very interested in how you manage to run Docker on RISC OS or RISC OS in Docker over Linux. Because this is actually something that we're discussing already on the forum. So this is a very, very interesting part of
it's dead easy. Because that's why it's taken me 1.5 years to get to this point. Yeah, Mum.
Not to mention 25 years of experience beforehand.
There's a bit of that as well. Yeah. So doing RISC OS work after coming back for many years, it's surprising. So there's a lot of things that I just don't remember, and there's a lot of things that just come back to me. There's also a lot of things that I've implemented when I've been doing things and gone, oh, that should work, and then realized I've actually that's not how it works at all. And in reading the PRMs and other documentation, I've realized that my memory is as infallible as everybody else's. Hey ho. So we had a question, what version of RISC OS is being used? So before I answer that one, does anybody have any other questions? Because that's the next section. Okay. So the version of RISC OS that is being used is RISC OS Pyromaniac, which I will now talk about. We're going to jump back in time into that gap that I said we'd come back to. I'd spent some time porting the tools and making things build on macOS and Linux so that I could build a reasonable portion of the software that I'd put into source control. And if you remember from the background section, I talked about how important testing was. JFPatch-as-a-service is an amusing offshoot from the main goal of testing RISC OS things. It took about a month to create that service and the site, just doing things in the evening after my day job, like I would normally do. The build client and the automation actually came a little bit later, so it wasn't quite all there at day one, but the main service isn't that different from how it was originally released. But the service is just a bit of a distraction from the main work over the last year and a half. RISC OS Pyromaniac, as I've said, is the service that powers JFPatch-as-a-service. The name didn't come until much later, and thank you to Chris for that name, because otherwise it would still be called Test Run. Let's talk a little bit about how that came to be. How do you test software without the operating system it runs on? My RISC PC is all the way on the other side of town. This was back when we didn't have lockdowns, so it would have actually been possible to get there and go and get it out, but it's the other side of town. And it's not a good system for doing testing on. As I said, if something goes wrong, I'll have to reboot it, and that's not nice for testing. But early versions of RISC OS, when it was originally written, were semi-hosted from a BBC. The BBC does all the keyboard, the disk, the video, and the ARM system does the actual running of programs. And that's what I wanted to be able to do. I want to be able to drive RISC OS from the command line of a more sensible machine. And in my case, more sensible machine means my MacBook or my Linux server. So surely that's really simple. You just run an emulation system until it hits a SWI, and then you make the SWI do whatever I/O it needs to do, and then you emulate some more. And that's the core of Pyromaniac. The first thing it ran was a tool that calls a few system calls to check if a file exists, and then runs a command if so. We know this as if there. The I/O part of the process is actually pretty involved. So whilst I managed to get a tool running, it wasn't that impressive. The two SWIs that worked were osfile17 to read whether a file was there, and oscilly, which just said, I'm not supported. But it did run. And a lot has been developed since then. This is the basic execution sequence in Pyromaniac. You load some code, you emulate it for a bit, and then you decide why the emulation stopped. If it was a timer, you go and run some timer events, and that's it. They don't do very much. If it was an exception, you report it and you end. If it was a SWI, you have to decide what it is and you run it. And then you decide what to do. If there was no error from the SWI, you go and check your timers and you run again. If it was a SWI, what did have an error, you've got to decide what to do. If it was an XY, you just set the V flag and you return back to the emulation. If it wasn't, you report the error and you're done. And that's it. But the devil is in the detail, and this run the SWI and run the timer events, and actually all of this is actually quite hard. Let's not dive into how it works just yet. Let's start from what Pyromaniac actually is. It's an alternative implementation of RISC OS. It doesn't use what went before in the core systems. It can still run ARM binaries through emulation, but the OS is written at in a high-level language. And that's so it can be used to try things out, to experiment, and to test things. It's a lot easier in a high-level language to replace an interface or change the way that something works. Similarly, it's a lot easier to reason about what the system is doing in a high-level language. You're not bogged down by worrying about which flags are set and what your registers hold. And having been written from scratch, it's easier to make shortcuts for things you don't care about. There's a lot of BBC heritage in there that you can just drop. Did you know that the video system can change the orientation so that characters proceed down the screen instead of across? Did you know that the system can scroll text sideways if you do that? That's something you can drop if it's not part of the environment you're trying to exercise. If you want to try it, that's VDU 2316. And actually it is implemented in Pyromaniac as well. But I wanted an example of something that was quite obscure that most people would never encounter. Strictly, Pyromaniac is the system for running ARM binaries in a useful way. That's the hardware, if you like. And RISC OS is what's implemented on top of that, the whole being RISC OS Pyromaniac. But it doesn't really matter, and I refer to it as Pyromaniac. You'll hear me talk about RISC OS Classic. That's to distinguish the implementation of RISC OS. At one point, I called it RISC OS Original, but that implies it's been surpassed, and that's not the case. RISC OS is the operating system interfaces. Classic is an implementation of those interfaces, and Pyromaniac is another implementation of those interfaces. If you remember it, you might well like to think of GNU Herd and GNU Linux as the distinction. If you haven't guessed, it's written in Python. It's largely modular internally, with subsystems separated into individual Python files. I use the Python Unicorn package to emulate ARM code. I looked at a few different emulation solutions, but Unicorn is really nice. Other than Unicorn, though, nothing else is required by Pyromaniac. If you need to run a UI, you'll need GTK or WX-Python. If you want sound, you'll want RT MIDI and the MIDI synthesizer, but you don't need them. Without those modules, Pyromaniac will just track the current state. If you try to play a sound, but the Python module isn't present, the call will say it was successful, but you won't get any sound. And if you're testing code, you just need to know that the call works, and that's good enough. This is the general architecture of Pyromaniac at a very high level. The bit you run is the harness, pyro.py. And this just uses Pyromaniac and RISC OS interfaces to set up the environment. Pyromaniac itself provides setup of the environment and some support functions. This is the only part of the system that communicates with Unicorn. So if a different emulation layer were to be required, it could be substituted here. The kernel and many of the Python modules sit above this, and they provide the interfaces to RISC OS and its subsystems. There's a separate Python file for most of the subsystems. By default, Pyromaniac initializes only one RISC OS module, the utility module. In this form, it's very limited, but actually that's what you want if you're providing a test and debug system. The other internal modules can be initialized with a single option to the command line, which brings in many of the common functions that you expect from the OS. These Python modules, or Py modules as I've termed them to distinguish them from the ARM counterparts, have almost the same functionality that the original versions have. They actually have exactly the same interface internally because they're descending from the same class. which means that to all intents and purposes, they work exactly the same. However, instead of dispatching RISC OS calls to Python, as Py modules do, the regular ARM modules execute code through emulation. And finally, at the top, there's the application that you're running, which is always in ARM. So how is it different from other systems? Probably most of you know RPCMU and RChem. These are hardware emulators. They emulate as much of the machine's hardware as they can. And if they do their job right, the OS and the applications are oblivious. Most of the work that goes into doing that means getting the hardware emulation right. There's no operating system interface emulation at all. The OS that is running is the OS that you originally were supplied with no changes. Pyromaniac doesn't provide any hardware emulation at all. It works at just the OS interface level. RISC OS may be a dim memory for some people. It was a project to provide an emulation at the SWI level for RISC OS applications and to use an emulation system to handle ARM code. And that's really quite similar to what Pyromaniac does. There's a Linux port of RISC OS that uses the host system interfaces to trap execution on an ARM system and emulation on a non-ARM system. Some of the interactions with the host system are through special interfaces, but if I've understood correctly, that's the exception rather than the norm. It's a hybrid system that emulates a hardware environment with some interfaces to the host system. And that's kind of similar, but with more hardwareness in it. Last month, we were introduced to Amethyst, which is an ARM code execution system for unit testing on non-ARM systems. It isn't an OS emulator, and I've spoken a little bit to Jason. That was not his intention in what he was trying to do, but it's intended to check whether the individual units of code work properly. Amethyst is incredibly similar to Pyromaniac in its goal of being able to test code on an alien system, and that's really similar to what we're trying to do. However, with Pyromaniac, I wanted to be able to test real interactions within the system. The difference is one of intent, really. Amethyst intends to unit test well. Pyromaniac aims for system and integration testing. And I think they complement each other quite well. If you haven't come across Wine, it's an x86 interface layer for Windows applications. And it will take a Windows application and allow you to run it on Linux and macOS. The Windows application thinks it's talking to Windows because that's the interface it calls, but those interfaces get translated into native operations on the host system. Because it's running x86 on x86 or x64, it's not emulation, but it is replacing the interfaces with those that have the same effect. And that's kind of similar to what Pyromaniac does. Although Pyromaniac is providing the interface at the system call level, not the linker level. It's slightly different. Docker is the most different in terms of what it's doing. It uses Linux kernel isolation and the capabilities interface to isolate the execution of Linux applications. It's only superficially similar to Pyromaniac. And Rosetta is a technology used on macOS systems. It allows you to run the prior architecture on a newer system. The original version was to cope with PowerPC to Intel transitions, and Rosetta 2 copes with Intel to ARM. In both cases, the application is being translated from the old architecture to the new one, but the interfaces that are invoked are the same. Direct analogs of the interfaces exist in the new architecture, and that allows the translation to be performed at the application level and not deal with the OS libraries at all. So they're kind of similar in that they let you run applications from an alien architecture, but otherwise they're quite different. So how does that compare to a bare operating system? Well, Pyromaniac has many of the things that you might expect from a regular operating system. It still has to worry about allocating memory and taking calls from user space. It still has to be able to handle I/O for those applications, whether it be keyboards, file system, sound, or whatever. And it still has to have device drivers so that you can talk to the outside world. But it doesn't have to worry about many of the things that a real OS does. You have no idea how glad I am to not have to worry about page tables, TLBs, and cache coherency. Without real hardware, there's no need to provide interrupt masking, prioritization, and bus discovery. And with no physical chips, you don't have memory map devices to probe registers with. There's no clocks to set, no instruction set features to worry about. And I am over the moon to not have to deal with those things. So what does it mean? Well, it's a command line focused system that means I can run most command line tools. Remember, the goal is for testing and experimentation. So command line and core systems are vital to that. Because it's written in Python and uses Unicorn, which runs on different systems, Pyromaniac runs on macOS, Linux, and Windows. The core system is all new code written from scratch, although it doesn't cover all of the OS. So when you run BASIC, for example, you have to use the ARM version, not a custom version. The code for the operating system itself, though, is all new. The point of the system is to be able to test and to find problems. There's a lot of configurability in the system and a large number of options for debugging and tracing code. And I should acknowledge that this is a technology that I've created. It's a pretty niche technology, but it makes me laugh a lot. I asked my friend about my insecurities in doing this talk. I was worried that people would say, "Why are you doing this? Why are you telling us?" and not caring about an online service. And they told me, no, they'll be thinking, does it run impression? And when I did the talk at my current work, the question was, does it run Starfighter? No, it doesn't. It doesn't run impression because there's no desktop. There's a lot of command line, and there's a graphics system. And you can have graphics tools working without a desktop relatively well. When you're running tests, you're isolating the functionality and the interactions. So command line is just fine. So there's a distinction between different parts of the system. There's a VDU system, which handles character output and VDU4 output. There's a graphics system, which involves OSPlot, VDU5, draw fonts, and the like. There's usually a frame buffer, which is a bitmap of memory that holds that content. And there's a user interface, which is how you see the VDU and the graphics. The VDU system is pretty well supported. It can output as regular console applications. It can output as a regular console application in the host OS with plain text. Or you can use an ANSI text implementation, which translates RISC OS VDU codes to ANSI terminal codes. This means that if you send yellow text to RISC OS, it can output yellow text in the terminal. The graphics system is pretty well supported as well. It can output it can look pretty reasonable most of the time. There's still holes. For example, gcall actions other than plain plotting isn't supported yet. I don't support exclusive OR of content, unfortunately. But by and large, it works for simple things when you go through the standard interfaces. Normally on RISC OS, you have a frame buffer. That's a region of memory that holds a bitmap of what you're plotting. And that does not exist on Pyromaniac. In fact, there may not even be a frame buffer on the host side. Although you would normally have a graphics implementation that used a bitmap, it doesn't have to. If you change one of the configuration options, then instead of outputting to a bitmap, it'll write to an SVG, and you'll get a vector representation of the screen. And this is the reason why it doesn't run Doom or Starfighter, I'm afraid. Maybe at some point you could actually do that. And this is going off piste a little bit, but there is the scope for using accelerated interfaces. You could actually pass through 3D interfaces to RISC OS and just make them accelerated. But that's something that I might talk about later as well. Finally, there's the user interface, how you see things from the VDU and the graphics. VDU output, as I've mentioned, can come out on the console from your terminal. But the graphics output can be configured to be displayed in either WX widgets or GTK. If you don't know, those are two different frameworks for applications. Or it can be configured to not display anything, which is the configuration you get in the build service. And what you have to remember is that the VDU and graphics systems are pretty complicated. Remember the example of character direction from earlier? Well, there's a lot more of those. So let's have an example of how you use it. This example runs the harness with the internal modules and then runs a command line. Internal modules running a command line. And then you can enter *fx0 to get the OS information. There's no way to report the host system because RISC OS didn't have a host system. So I just tack that onto the end of the OS version. I report that Pyromaniac 0.16 running on Darwin on x86-64. And as you can see, I can run other commands and I can quit and return back to my host system. You can load modules at the command line and run programs. In this case, I'm creating a hello world program and writing it to a file. The program has file type FD1, which is basic text. And it uses the standard form for RISC OS file types on non-RISC OS systems. On the command line, I need to load basic before I can use it. Basic isn't part of Pyromaniac, so you have to supply your own. And as you can see, it does print out hello world. Okay, it's time for a demo of the graphics system. And that's what you've been watching for the past hour or so. This entire presentation has been executed entirely on RISC OS Pyromaniac. So that's demonstrating, firstly, that RISC OS Pyromaniac is a real thing. It demonstrates the font system. This isn't the classic font manager. It's using fonts from Cairo graphics system, which is a library available for lots of different systems and ported to Python. It uses the host's system fonts. All the font calls are implemented in the standard way using fonts-wise. So it works just as it would on RISC OS Classic, albeit with different fonts and therefore different metrics as well. In the corner down here, you can see my G logo. That's a draw file. And it's being rendered through image file render, which then calls the draw file module. And the draw file module just calls draw. Draw has been implemented in Pyromaniac so that it calls Cairo's path primitives. All the pictures you've seen up till now have been PNGs. And like draw files, they're rendered through image file render. They use a custom image file render module, which talks to Pillow. Pillow is a Python image library, and that can render lots of different file formats. I added WebP support recently, so I can now render WebP files. That also meant I had to go and register a file type for WebP. Hopefully, you've seen no flicker as we move between slides, and that's because different screen banks are being used. We render to the off-screen bank before we display it. You won't have seen flicker, but you might have seen the hourglass pop up. That's the hourglass. Hopefully that's animating for you. And that's actually just a standard RISC OS hourglass module, but implemented in Python. And there's key input. I'm pressing keys to move around. I can move backwards and forwards with the hour keys and turn the pointer on and off and things like that. And the entire presentation tool was written just so I could do this presentation. That's kind of why it's taken me 2.5 months to get to the point where I can do this presentation. So, small digression before I talk more about Pyromaniac, because there's a bunch of tech I've created here. The presentation tool I created for this talk is open source. It uses an open source Markdown parser. And these slides are all written in Markdown. The font selection uses my font map module that I created some years ago to find variants of fonts. You ask it for a named font and ask it to say, make that oblique, and it'll do it for you. It's not very impressive, but it does the job. The web colors module was created for my SVG converter. You give it a color name and it gives you a color. One job, and it does it well. And I'm using image file render for image rendering because it does what it says on the tin. Okay, oh, let me just see if there's any questions. No specific questions so far. Okay, let's move on. What works? Yeah. What can it do? We can run command line tools and modules, and that meets most of my goals for testing. You can interact with it. You can use the keyboard just as you might expect. In the UI, you can use the mouse. You saw my pointer moving around. You can draw things with the VGU interface. Draw and Font Manager are supplied, but we don't have a frame buffer. Direct screen access does not exist, and it's unlikely to with the current implementation. It could, but it's not there. We also don't have sprites because they're also direct access. Sound channels is provided, and it maps the sounds to MIDI devices. Each of the standard voice names is mapped to a general MIDI instrument that approximates the sound. The sound system actually works more like the BBC sound system, if you prefer it to. And the reason for that is because I forgot how the RISC OS sound system works, and instead I implemented it using the queuing from the BBC B. So I've now implemented the RISC OS version, and you can switch between them, which means you can run your old BBC, the programs from the BBC that used to play tunes, and they work. I use an example of Hall of the Mountain King as my test, which was in an ancient BBC music book. You can access the local file system, so you can get files that you're testing into the system. Or you can load file switch and access a regular RISC OS file system. It uses the host network stack from RISC OS, as if you were just calling normal sockets-wise. We try to map the sockets-wise through as much as we can. If the host has IPv6, then ifconfig will show you that. I've updated ifconfig so that it can do that. And you can connect to those addresses as well. And for compatibility, it's RISC OS. So whilst not all of the interfaces have been implemented, many things do work. It really depends on how complete those implementations are and how forgiving the application is. Not everything checks whether errors were returned or that the state was not what it was expecting. Sometimes you don't care because you just want to test something out. And generally, the support for given interfaces varies between the level of Arthur and Select. There's a few RISC OS 5 things thrown in, but to be honest, there's not a lot in RISC OS 5 that's actually much advanced for this type of system. The actual features document, which is made available at the end, is about 70K of plain text, and you'll be able to see that at the end. What doesn't work? So we don't have a desktop, but question from Stuart Swales, if you load file switch, is there a Pyro host FS? No, there isn't a Pyro host FS because I haven't got round to it yet. I actually have implemented all the file system interfaces at the file v, GBPV, and those levels. So I'm providing essentially my own file switch. I haven't quite got around to making it work with regular file switch, but I plan to. So that will be coming when I get there. Okay. Sorry, I've lost where I am now. What doesn't work? Yes. We don't support the desktop, but we do have certain interfaces to appease things that expect those interfaces. So there is a task window module and there is a task manager module, but both of those just return there is only one task, or you're in a task window and that's it. Or you're not in a task window. You can configure it either way. There's no support for 8-bit or 16-bit sound. Although after Jason's talk last week, I was inspired to implement SoundDMA on an experimental branch, and I can now play WaveSynth through Pyromaniac. It is experimental. It doesn't work especially well, but it does work. Continuing work on that. So for graphics, Sprite is quite hard because it's direct memory access. And I've not got around to implementing them yet. And paletted modes are also quite hard, but they're a case for getting things wrong. So I've kind of implemented them first, and I don't have 24-bit modes yet. But the paletted modes are actually implemented in a 24-bit mode. So if you try to palette cycle, that doesn't work. What you've got on the screen stays as it is. That's what you get. And you don't get flashing colors, and you don't have a text cursor that flashes either. And actually, the reason you don't have a text cursor flashing is because it's a testing and experimentation system. If you start adding in interrupts for flashing the cursor and things, that makes testing a lot harder. So I haven't implemented it yet. I could, and then just have it turn offable, but I haven't got around to it. And there's lots of other bits that are missing, either because they're less well-used cases, or I just haven't got around to doing it yet. Remember, this is just me doing it because I think it's fun. So, networking. The Internet module supports IPv4 and IPv6 if that's what your host has. And it allows you to connect to or serve to hosts on local network or the internet if that's how you've got it configured. Interface enumeration and socket operations have been extended to support sockadra in 6. If you don't know, the sockadra structures are defined for each of the different types of interfaces you can have. So sockadra in 6 is a standard structure that's used by BSD and Linux. And we support Pyromaniac supports the BSD sockadra in structure, which when we get a BSD stack will work with it. So it should, in theory, work with any other applications that are built for the Internet module. The Resolver module can do lookups for names and addresses, but it only supports IPv4 because at the moment there isn't a Resolver extension for IPv6. Once that comes about, I'll implement it. On the other hand, you can load a classic MBUF manager and a classic Internet module, and I've got an Ether Pyromaniac module. And that's a DCI4 driver that allows you to talk to a virtual network. That driver basically allows you to connect to other systems or other Pyromaniacs. The virtual network is actually a set of frames transmitted in JSON over a TCP connection. The other end of the connection could be another Pyromaniac or a virtual hub. And the virtual hub could connect many instances of Pyromaniac together or onto a tap, which talks to a real interface. We also support easy sockets, and that's because I implemented it bypassing internet entirely. As a result, I connected some IRC servers early on in the development, somewhere around October or something last year. And I hadn't realized it, but I was connecting over IPv6. It just worked, which is kind of the point of easy sockets. It was meant to abstract away the difficulty of connecting to things. So that was quite nice. I've mentioned that I can render draw files and that it goes through the Cairo path rendering. But it's also possible to load the classic draw module as well. If you didn't know, the draw module puts lines on the screen by calling the hline interface. You can find that by calling os read VDU variables. On select, there's also a poly hline interface, so it can work faster on accelerated systems. In Pyromaniac, though, hline is implemented by a call to the Cairo line drawing system, which means that if you load the classic draw module, it can still draw to the screen. Obviously, it's not just the simple G that can be rendered. My brother drew this about 25 years ago in Artworks. This is actually rendered in draw because Artworks will only render to a frame buffer. But draw file rendering works just fine. I mentioned the font manager, but specifically, it only uses the toy interface that Cairo provides. At some point, I'll look at using Pango so that it can provide more flexibility, but it works pretty well for most simple things. There's a few limitations, like my font manager doesn't support font control strings, and transforms aren't supported, but I will get to them eventually. It does support encodings, though. If you request UTF-8 encoding for your font, it'll use it. And this presentation is all using UTF-8. Those bullet points are UTF-8 characters. You can also load the classic font manager as well. But you have to turn off the bitmap caching because that uses sprites. If you turn off the bitmap caching by setting the font max to 0, it'll just call draw for everything. And as I've said, draw works. So let's have a look. Let's have a look at the core features, some of the more of the core features. Because Pyromaniac is intended as a debug tool, it needs to be configurable. It's not a case of one size fits all. Sometimes those configurations make the system safer by removing access to the host. The service uses these features to limit the host system access. You don't want your person who's building a JFPatch module to also go off and turn the machine off. That might be annoying. So the first example here, this one, turns on the noisy ROM initialization. This is akin to the option of the same name in the RISC OS kernel. And it prints out more information about the ROM as it starts. The second example changes the location in memory that hosts the ROM, and then shows you where the modules were loaded. You can also give it whole configuration files. These make it easier to specify groups of options without long command lines. This example is from a part of the configuration file that I use for testing the booting of RISC OS 5 ROMs. The format is YAML, so it's nice and readable, and you can hopefully understand what it's trying to do here. I turn on some debug. I've configured what extension ROM I want to use. Extension ROMs are implemented as podules, so you can just give it a ROM there, although I only implement one of them. You can configure other things should you wish to. I need to move my ROM out of the way because the rest of the system expects things to be in particular places. And these configuration files make it a lot easier to use groups of settings reproducibly, which is really important in testing. So I created this file back in, I think I created it back in November last year, something around there anyway. And earlier today, I tried out just to see, does it still work? Yeah, it does. I don't have to remember all those command line options that I needed to supply to get RISC OS 5 booting. Well, not RISC OS 5, but the RISC OS 5 modules. It just worked, which was kind of nice to do. It also reminded me that there's some bugs in RISC OS 5 that I meant to report. So I've just reported those today. The point of Pyromaniac is to make it easier to debug and test. It has a few different ways of doing this and reporting different progress through the code. Tracing instructions is really easy, but it slows down the execution massively. Cheaper operations are to trace SWI calls or to trap specific memory accesses. The instruction trace is also able to elide loops as well. So if you're sitting in a tight loop going round and round the same instructions, it won't write that to a log file thousands and thousands of times and give you megabytes of data. There's also copious debug available. So you can turn on debug for just the system you're interested in seeing what's going on with. So it really depends on what you're trying to find out as to what type of tracing or debugging you might want. The example here is showing the tracing of SWI arguments when a SWI is called. The debug uses a built-in table of names and the types of SWI parameters to show what the registers mean. Here we can see that the basic command gcol has been called, and that's triggered a call to the color trans module's set gcol system call. And it shows what the parameters were on entry and on exit. The information on what those SWIs are was extracted from oslib def files. I wrote an oslib def file parser that you could use to extract the information in a format I can use. The parser also generates templates for Py modules and for other cases. And the parser is open source. It's also possible to debug the instructions that are being executed explicitly. In this mode, the system is disassembling as it executes the code. It can report the registers and the memory as it's running. Here you can see what the memory was pointed to, different values as they were happening. This is one of the tests for Pyromaniac that exercises the reading of the current time as a string. And at the end, SWI feed05 or feed-os is used to return back to the os. This example shows a couple of the subsystem debug options: the command line interpreter and aliasing, and the FS control interfaces. You can see that the debug is interleaved with the output from the command itself. This shows what the system is doing at each of those stages. And the command line system is actually surprisingly complicated. I think I've got most of it right, but there's bound to be some differences. At the moment, there's things like the redirection that I don't support. Well, I kind of support, but it's actually kind of hard to get right. So what is it like to work with? Well, I think the code's pretty well structured. Every function or method has access to the row object. This is a reference to the root Pyromaniac object, and it holds all the information about system execution, the kernel, and that's where all the internal resources can be accessed. The Pyromaniac object also handles configuration, so everything is going through the same interfaces. The whole system is able to be multiply instantiated. If you want to run two operating systems, you just start two objects. The kernel object holds all the subsystems. Some of those objects are simple. For example, the vectors object is really just a registration interface with a dispatcher. Others, like the dynamic areas, are much more complex, as they have many different operations to be performed on them through the RISC OS APIs. RISC OS components implemented in Python can also call any SWI, and they do this through the system APIs object. This ensures that calls are processed as if they had been issued by the classic system. So let's have some quick examples of the code itself. This is the implementation of os read escape state. It's an incredibly simple SWI call, which just returns whether the escape key has been pressed in a flag. As you can see from the implementation, that's exactly what it does. It updates the C flag in the processor state, to reflect the escape condition from the program environment. The registers object actually handles all the numbered registers. But here, the processor flags are being manipulated. In ARM, those processor flags live in a virtual register, the CPSR. There's a property setter which allows us to manipulate the particular flags we want, like the C flag, just by writing to them with a Boolean value. And finally, the whole thing is registered using a decorator. So this tells it, remember this function as the handler for OS read escape state. This is a method from one of the Py modules. It implements a command to load a new RISC OS module. As I think Stuart was telling us a few weeks back, most of the RISC OS interfaces are implemented as just very small veneers onto the main system call. So your star commands are just the system call, and that's all you see here. It literally just calls the underlying system call. And you can notice that there's no error handling at all, because there doesn't need to be. If the OS module call generates an error, it'll get raised and handled by the caller of this command. We only need to do any more handling for errors if we need to clean up any resources. In ARM, you might allocate memory on the stack to store some temporary strings. And that's not as easy in Pyromaniac. It can be done, but it's just not as easy. So it's simpler to just allocate some memory from a heap, which is what we're doing here. We're allocating some memory from the system heap, and then we're using it as a time string. We need somewhere to store it, so we use it in a context handler here. The context handler allows memory to be allocated, and when the block is exited, the memory will be automatically freed. The result is finally written to the screen using a writeLn call. And the kernel object can actually be used as an I/O output, which means you can use it just like any other file handle. This is a little more complicated. This is the implementation of *show. And here we use a context handler to handle the paging mode. When you enter this context handler, page mode is turned on, and when you leave it, page mode is restored back to its original state. This means that when output reaches the end of the screen, you have to do something. In classic RISC OS, you'd press Shift to allow it to advance. We enumerate through the variables using a for loop, and regular variables are printed out using GSTrans escaping. The GSTrans Python module supports both decoding and encoding to make this easier. And then we construct a suffix for the type of variable that's present. Finally, we send it to the VDU system. Not everything is simple, though. Some things that can be made easily in RISC OS Classic don't have simple translations to Python code. But mostly it's a matter of implementing what you need as you need it. And fortunately, I know most of RISC OS pretty well. A couple of months ago, I found myself saying, oh dear gosh, message trans enumerate tokens is tedious, as I found I needed to implement it. And then 10 minutes later, I had an implementation and it was working. And it's really nice to find something that you think that's really tedious on RISC OS, just takes 10 minutes to implement and implement relatively well. That's not how I remember it on RISC OS Classic. I remember lots of pain with those sorts of things. I mentioned that errors are handled by the caller, but sometimes you do need to trap them. In ARM, you would call the SWI with the X-bit set, and you would check the error codes. In Python, it's the same pattern, except you don't call it with the X-bit set, but you trap an exception instead, and then you check the error code if that's what you're looking for. It's an operating system. But can you actually do anything with it? I wrote this presentation software without touching any part of RISC OS Classic. Does this presentation tool work on Classic? Yes, but not first go. And the reason it didn't work first go was that I'd built font map wrongly. One of those tools that I built, one of the ResGen tools, had not been converted to 64-bit properly, and the result was that loading it on Classic broke both ResourceFS and message trans. And because the system was dependent on that, it meant you had to reboot immediately. The presentation tool itself didn't work from the desktop. I'd forgotten that there's a WIMP command window pending, which you have to clear, otherwise you get odd effects. That was relatively easy to fix. And then I came to run it on RISC OS 5, and it stiffs the machine. I'd fixed the things that I thought were wrong, but clearly I was doing something odd. But what? It turns out on RISC OS 5, if you select an out-of-bounds screen bank, it gets very upset. And there was a bug in my code that meant that I was selecting the wrong bank, which should be entirely benign, but was killing the machine. So I've raised that in the forums yesterday, I think. But those two major problems resulted in reboots during development. And it backs up my original assertion that RISC OS is bad for testing. But could those problems have been found with Pyromaniac? Firstly, if it did get into a bad state, it would probably still mean killing the operating system. But that's just killing a process, and you pretty much expect that. On the other hand, the font map problem didn't trigger any issues at all because I haven't implemented ResourceFS yet. So it would have found them, and yesterday I implemented a good chunk of ResourceFS and proved to myself that it would have found that. I now have ResourceFS largely implemented. The bang selection probably wouldn't have been found unless I was looking for it though. You see, I implemented screen bank selection as a hash of bank numbers, and you use a bank and it comes into existence. It didn't care about the bounds checking, even though it did it, it just didn't report a misuse or anything. So a couple of days ago, I added some code to go and generate warnings if you use the wrong bank number. What other things does Pyromaniac help with? Well, the build service, which was just a fun project, is pretty functional. And you can build things pretty well. And I get a chance to try out things I wouldn't be able to. So I mentioned Jason Tribeck's sound system earlier. During his talk last week, I was reading his specification and I started implementing his sound system module in Pyromaniac in Python. I only spent 3 hours on it, but I gave him some hopefully useful input to say, this is difficult, this is harder, this is not documented, I guessed on this. So hopefully that was useful to him. And you can see the source to this. The sound system source is linked at the end of the talk to give you an example of what this code looks like. And then there's a chance to debug other people's software as well. Julie Stamp released an early version of an obey module that they'd written. And I will say, I am incredibly impressed that anybody managed to do that and do it in C. Great kudos, wonderful thing. And I was able to try it out and see how well it worked because it was implemented for RISC OS Classic. This is a totally different RISC OS. How was it going to deal with that? It pretty much worked, which was really cool. But the things that didn't, I could record. And so I have an AskCinema recording. If you haven't come across AskCinema, it's a way of recording textual output and have it replay as a little video. And so I have a little recording of her module running and what I found. And this is the trace that I got out of it. I've elided some bits because it was a little bit heavy and would have made very, very tiny text. Unfortunately, they had freed the stack that they were executing from. And when they returned, they had a very bad day because they returned invalid memory. The PC ended up being A9, 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 AC. And unfortunately, Pyromaniac is not a reversible debugger, so I can't go back in time. That's my day job. So I have to deal with the aftermath of the crash. But that's okay, because I can just run it again with block tracing enabled. This is the block tracing you can see here. It's printing out every single thing that was leading up to that particular instruction. And you can see that it hit a memset function, which is it clearing the stack. And then you can see from that where it came from, and you can then set a breakpoint on that and run it again and see where it came, how it got there. Lots of stuff works, but there's some stuff that doesn't. And I still have some stuff to fix. As I mentioned previously, I don't have interrupts, but I do have timed events because I need them. Parts of the network system won't work if you can't carry out timed operations. The spinning hourglass wouldn't work without timers. And these are actually implemented in a check at the end of the execution to see if there's anything outstanding. You saw that in the execution diagram. It's tacky, but it's good enough. Whereas on classic RISC OS, the execution state would be entirely in the memory of the machine. In Pyromaniac, it's split between Python and the emulated system. And that makes it a little bit hard to see what's going on sometimes. This is a problem that most emulation systems have. And it's worse because it's the OS state that's split between the two. My error handling is still not quite right. I made a design decision early on that still needs fixing. Errors are handled as Python exceptions, but I haven't differentiated between signaling and non-signaling errors. It hasn't hurt yet, but it will. So I'll need to fix it sometime. And whilst I'm not writing C or ARM code to poke hardware registers, I'm instead writing interfaces to Cairo, to Sound Device, GTK, and others. It's just replaced one problem area with another. In doing this, I've created a whole bunch of other technologies. I've called out some of those as we went along, but here are some of the others. There's a Python package for handling RISC OS alphabets as Python codecs. There's some syntax coloring modes for the two editors I use regularly, Sublime Text and Nano. I've mentioned earlier that I've created a syntax mode in CodeMirror. I built some Hourglass modules just to see how they worked before I started implementing one in Python. To make it possible to test the compiler, I wrote a tool that allows me to test tools. It runs the tool, captures the output, and compares to what's expected. It's an expectation processor for system testing. It works on RISC OS and on Linux and Mac OS. For the toolchain, it supports parsing some parts of AOF, ALF, and ELF files. And it's Perl 5.0 compatible so that it can be run on the last Perl that I have for RISC OS. There is a later version of Perl, but I don't know whether it supports RISC OS style file names or not. And that was important to me. I've created a public repository of RISC OS tests called, I think, RISC OS tests, which uses this tool. The repository has a selection of the tests from Pyromaniac in it. However, those same tests could work with RISC OS Classic if people wanted to do that. And people could contribute new tests that exercise other parts of the system. If anybody wants to raise PRs or just submit code that would be useful for testing interfaces, please let me know and I'll try and integrate them into the system. To document some of the things I've been working on, I revisited and resurrected the PRM in XML format documentation. I've just realized probably people don't know about this. PRM in XML is an XML format that describes, in terms of the PRM, what interfaces there are. So you've got special structures to define SWIs and services and errors and describe the sections in the way that the PRM does, because the PRMs are really awesome at trying to explain things. And my PRM in XML project was to produce style sheets that could generate HTML, strong help, and text versions of that. There was a PDF conversion of that, but I don't know where that got to. That was largely done by ROUGOL after I left. And there's also changelog management as well, because I like creating branches for little features and just keep them alive as long as those features need to be developed. But I end up with merge conflicts in the changelogs. So I have a special changelog management system. So I've done this presentation on macOS using WX widgets as the UI, but it runs on Linux and Windows. When I did the presentation at work, I ran it on Linux because that's my work machine. I've built applications so you can run them on macOS and Windows. And I've built Docker containers so you can put the OS inside it. JFPatch-as-a-service is just a customized Docker container. It has JFPatch and other tools in it. And I have a private registry with my Docker containers in. The CI system will perform updates and push to the registry every time I make a change to those tools. I haven't got around to doing automated testing on Windows yet. That's a little bit more complicated. Eventually, because it's a good bit of a challenge. And actually, I've got some Windows challenges at work, so it'll be a way of learning about that as well. So once a month, I go through a release process. I update the features document, the main product documentation. I do manual testing on the different platforms. I update the version number and so on. And if I'm only doing this for myself, why do I bother? Well, it's another thing that helps me feel good about what I've done, and I can see what I've achieved. There are some branches that have hung around for a while because they're okay, but they don't make the cut for release. And I have tasks on my board to review those different branches. And I raise issues when I find something's wrong. There's a special Pyromaniac Git branch that lets you use the host Git client with RISC OS file names. It's been there since June, and it's working, but it needs a lot more to make it work sensibly. And I've not had a picture in quite a while. So here's what it looks like for my horrible branching system. That's where I'm trying to sort out some of the mess that I've got into whilst I've been trying to make this presentation work. So this concludes the section on Pyromaniac, but I'm not going to take questions just yet. Sorry. I just want to go through the very last section, which is the conclusion, because it is quite short. There are a few things that I set out to do when I was talking about this in the background section. So let's have a look at each of them. These are the things I saw as features of modern development. Did I manage to achieve my goals? So source control. Everything is in source control and I can access it. Cross-compiling. I can build RISC OS components on macOS and on Linux. Manage development environments. I've got multiple ways of controlling my builds. Automated testing. I've created JFPatch-as-a-service for that purpose, that other people can do testing. And internally, I use my own CI for my things. Feature and regression testing. I have thousands of tests, well, 1,000 for Pyromaniac. I don't actually have fleets of machines available, mostly because I don't need to. I have a hefty server at home that I can use multiple builds at once, and I've not need for much more. And the JFPatch-as-a-service system only needs to provide for one thing at a time, really. I haven't been tracking its use, but I can pretty much guarantee that there's been nobody who's touched it for probably since April. You'll remember that I said that RISC OS testing is awful. Well, it is for RISC OS Classic, but RISC OS Pyromaniac has tests for many of its interfaces, and it runs them on multiple platforms, and it runs them on each push. Each of those 1,000 tests starts RISC OS, executes the tests, and then exits it. So each environment is clean, and you're only testing the things you're interested in. Doing that with RISC OS Classic would be impractical. It's just not able to do things quickly and reliably in that way. I hope that somebody takes that as a challenge and goes and makes that possible with Classic. But that's for somebody else to do. Essentially, I'm booting RISC OS thousands of times per day to test its behavior does not get any worse. There aren't enough tests, and there never are. But I try to make sure that there are at least some feature tests for each major change that happens. And that's what I do in the release process. I decide whether there's enough and whether branches can go in. And I run code coverage checks on that to see that I am actually testing parts of the code I've written. 65% is not terrible. It's not great, but it's not terrible. And some things will always be hard to test, but it's looking good, I think. The other part of the statement about testing was that RISC OS is awful for testing. After all, you may remember that the stated goal, the whole reason for starting doing this, was that I wanted to test things in a sensible way. RISC OS Pyromaniac makes it possible to test in a less awful way. The environment can be controlled, errors can be trapped, execution time can be limited, and you can restart it. JFPatch wasn't that bad to put through tests using Pyromaniac. There's still some things to be improved, but what was important was that I could see that I wasn't breaking things when I added 32-bit support. So I added tests first to see that I could parse files, then added 32-bit code, and I could actually see that I exercised that code in Pyromaniac. Could it be better? Of course. There are huge swathes of things I've not talked about here. Subtleties, things that work, things that don't work, and ideas that might never pan out, but which would be really cool. And I could talk for an hour on any part of these things, and there's a lot more for me to do. But I try not to feel guilty about that, because the whole point of this was so that I could do something that I enjoy. You'll find some reference material, including these slides, on the pyromaniac.riscos.online website. Feel free to try out the shell server. You can try that out with many people connecting at once. But there's one more thing that I set out to do when I started all this work. The great and liberating thing about all of this is that none of it matters one jot whether it happens. The only thing that matters is whether I feel it would be fun and whether it would make me happy to do it. And that's the thing I learned a year and a half ago. And that's what powers the service that you see. It's my happiness. And that is the end of my talk. So I will take any questions that people have now and any things that I've missed in the chat.
Right. Thank you very much. Actually, this was absolutely fantastic. And thank you very much for the end of it, because this is basically my life philosophy as well. So, and it's great to see someone else sharing it as well, because I strongly believe that if we bring fun back into the RISC OS, now regardless, obviously you're a fantastic developer, but even people that are less talented, still having fun, still sharing fun, will bring a much more optimistic and positive atmosphere around the OS. So thank you.
I think that's very important. I think that one of the reasons that I find it difficult interacting with the RISC OS community is that I take a lot of things very personally. And thank you. And when I get comments that are negative, even if they're genuine criticisms, I find that very hard. And sometimes the RISC OS community can be really, really harsh. And I find that very difficult. So I run away from that. And this is the reason why I found it hard to come and do this talk. It's one of the ways of challenging myself to do that. I'll want to be quite clear. RISC OS Pyromaniac is not available for people to use themselves at the moment. I do not feel comfortable giving it out to the world just yet. However, if people have a genuine interest and they want to try things out, I've already offered this to Andrew, although it was not ready at the time that I offered it. I've offered it to Jason as well, if he wishes to use it for parts of his testing with Pyromaniac. If people want to use it for other things in a closed environment where they can give me feedback and just try things out, I'll be happy with that. Hopefully that will improve my confidence to be able to bring it out to the rest of the world. But I have released a huge, well, I think it's a huge amount of things. If you have a glance at the pyromaniac.riscos online site, you'll see under the technologies side, there is a lot of open source software that I have made available. Any questions?
Hi, Gerph, it's Nathan. I know we've had a few emails backwards and forwards over the past few weeks. Yeah, I'm not a coder, so some of your stuff went over my head, but I was mightily impressed. And how many operating systems are built on happiness, really? So I'm sure I'm speaking to everyone here, but absolutely amazing stuff. Very impressive talk. You are a very impressive person, and I totally understand, certainly from my old times in RISC OS, how there was a lot of negativity with just a small minority of people, and I suspect those people have now gone. But well done, mate. That's fantastic. Brilliant presentation.
Appreciated. And I think there are still people who are negative, and I want to be very clear about the negativity. There is a difference between people being negative for the sake of it and people being critical and giving constructive feedback. I sometimes do not take things as constructive feedback when they were intended that way. That is on me. But there are people that do sometimes come across as negative, and sometimes not escalating discussions that go badly, I've found hard over the past, and I'm sure that happens right now. I honestly have not been following the community because I get wound up. But some of the things I see are impressive. Some of the things I see are, why hasn't that been there? Because I did that some years ago, and yeah, that I'm not going to get into. But
feel the same way.
But things are being created. I mean, there are. I mean, I've glanced at some of the announced things, and I see things, and I think, dear gosh, really? Is that being done? And then I see other things, and I go, wow, somebody's created something that I just wouldn't even considered, and that's so cool. So there are both sides of those things, and I guess the things that are those things that are coming up that you think, well, that's pretty RISC OS 2 level, may not actually be that unsurprising. There are new RISC OS users coming in who are learning these things. They may not have encountered some of those things before, and they should be encouraged for that as well. Not saying that they aren't, but that's just, it's surprising when I'm an experienced person and I see something, oh, that's quite simple, but it's impressive for somebody. It's something they built that they couldn't do before. Wonderful. New users.
Silly question about the presentation component. Obviously, that was your big big surprise that caught us all off kilter. I'd like to say I saw it coming. Absolutely didn't.
It worked then.
Yeah, I saw the Mac framework across window framework across the top and kind of thought, oh, it's a shame we didn't hide the window furniture, not realizing it wasn't a macro. You know, like, well. So well done. What language did you code the?
It's all in C.
That was in C. Okay.
Yeah, that's all open source.
Okay.
I'm not sure I've put a license on it, but it will be BSD or MIT. If you personally or any of your people wish to take it over, please, I'm not going to do anything further with it, although I will be doing my presentations at work using it because I've got it now. But feel free, it's not desktop, it's all single screen, but it's modular. It's open source, do what you want.
No, it just looked cool, and I was curious as to how you'd done it. But you know what?
Yeah. Again, it's if you can build something that uses the tools that you've created, then that proves that it's useful. Was kind of the way I was going.
Absolutely. And then when you showed the, it's a shame I can't go back in the presentation to the particular slide. You had a series of layers of Pyromaniac. I think it would probably be about slide 60-ish, but
something like that, yeah.
and you showed some near the top with ARM modules, and next to that were Pi modules.
Yeah.
And then below that there were some other modules, and now I'm assuming that basically all of the modules are written in Python except for userland modules that are ARM.
Essentially, yes, that's pretty much what it is. I'm just going to try and find it because that would be useful. Yeah, 60. There we go. I didn't, of course, produce an index of what the pages were.
Yeah.
If I can find it, I can actually show it. And yeah, there we go. You were spot on. It was 63. It was. Can I share again? Is that going to work? There. So this is the one that Andrew's talking about. Yeah. So. Thank you. Right. So these Pi modules are just the regular. So some of the modules that we've got, but any of those can be replaced by the ARM modules.
Ah, okay.
So debugger, for example, will if you load debugger, then the Python version will be killed exactly as it would with a RISC OS module, and the new one will replace it. You can then do a kill of that and then an RM re-init, and the Python version will come back because that's the ROM version.
Gotcha.
The same is also true if you use the ROM loading for the RISC OS 5 ROM. So if you've got a RISC OS 5 ROM, you can then load other modules over it or replace them back to how they were, just like you would with RISC OS.
Okay, that was a bit that you referenced in your talk, but then you kind of jumped on from quite quickly, and I was very, very curious as to you showed basically a RISC OS 5 ROM being loaded as a module, but you didn't sort of say what the purpose of that what could be done with that.
Why? Yeah. So largely the reason for that was those are a bunch of RISC OS 5. RISC OS 5 contains a whole bunch of 32-bit modules that calls 32-bit APIs, and to prove to myself that it all worked and I wasn't killing the system, I thought I'd try it out and see what happened. And the result was it was surprisingly successful. I mean, I did not expect it to work quite as well as that. If I can find it, sorry, I'll just go and see if I've got the right window. I can actually give you a demonstration if you're interested.
Oh, yeah, it's just absolutely.
Give me a moment. Share. Oh,
so basically, you're using the RISC OS 5 ROM as basically a big lump of test modules to test in in Pyromaniac, essentially.
Pretty much, yeah. So if I've got it in my history, because I was testing it this afternoon.
Is what I did earlier.
Yeah, let's not redirect it out. Let's get rid of that. So this is it starting up. I do not know how well this will animate, but this is it starting RISC OS 5 modules with a bunch of debug that doesn't work. Oh, it crashed.
You've now joined the fabled developers where if it's going to go wrong, it's going to go wrong when you demonstrate it.
That's right. Yeah. So as the last thing I did when I was testing this afternoon, I left the parallel device driver present, yes. And the reason was it fails. So I can actually demonstrate what's going on here. In the trace, it comes down here. It calls OS memory 400 with a code 9, and that's a special call to read the address of IOMD. If it gets an error, it assumes, oh, I'm running on a pre-RISC PC system. But you're not.
No.
And it goes and says, I'll hard code the address of IOMD on pre-RISC PC, and then it goes and crashes.
As you'd expect.
As you'd expect, yeah. So there's things like that that you can find out. I mean, if I can scroll back far enough, too far. Just scroll, come on, down here. So I should be able to see. Here we go. This is a crash in the window manager. No, yeah, this is a failure in the window manager. When the window manager is initialized, it does a bunch of things. It calls off sprite op and then tries to branch off to do some things. It comes in here, tries to store the error pointer it's got back, stores it into the stack, restores the stack, and then corrupts the stack, and then goes and returns with that corrupted value. And so you get this invalid error pointer. So I've reported that out to the forums just this afternoon. But there are useful things like this. It can detect issues that you wouldn't otherwise see, and you can intentionally lobotomize the OS to trigger these sorts of problems. One of the things that I've added in is when you resize an area, it can initialize the area of the RMA so that it doesn't have zeros in it, for example. Okay. So you can, or when you free an area, when you get an area allocated, those sorts of things can be tested. Yeah, there's bits and pieces like that that can be done.
I have to say that's an extremely useful way to test the individual elements of a RISC OS 5 ROM.
It makes it quite amusing. This is using 527. It's the image that was produced in the Easy Start bundle. I could use any other, but that's just the image I've got to hand.
Yeah, why not?
Yeah, exactly. I mean, I was thinking about trying it with 528, but I couldn't be bothered. To be honest, 528 came out last week before, something like that. Yeah. And I've been literally just trying to finish this presentation and the support site in that time.
And the kind of things you're reporting, I very much doubt those would have changed since 527 anyway. So.
I very much doubt it. They're not likely to be. They're also not likely to be real problems unless you go into certain circumstances.
But when we're looking at going to new platforms and new directions with RISC OS, you don't want to have little things lurking.
That's right.
Get you in the backside.
If you can have a solid system before you start. I mean, the other thing is, from the same point of view, the 32-bit port work, certainly on my side, and I suspect from the paste side and so on, had the same effect of, oh yeah, we've got to rework these interfaces because they don't work right. They're going to fail in these circumstances. Just revisiting that code gives you some extra insight. Any questions in the chat here? Ooh.
I lost the chat.
There's a lot of chat. But, how do you escape from the? You should be able to press Control-C to. Control-C is escape in the shell. That was an answer to a question about how do you escape the basic auto line, or you can just close the connection and reconnect again, but you'll lose the context, obviously. I don't see any more questions. Have I missed anything? What's next? Says Paul. To be honest, tomorrow is sleep. So I really want to get the file systems working. So Stuart mentioned about a Pyro host FS. Getting file systems working so they actually interact with RISC OS file systems would be really cool. Because at the moment, it's either you're using the host system or you're using RISC OS systems, and that's not very nice. So that's one thing that I'd like to get done. I've got about 100 tickets outstanding for things. One thing that's really interesting to me, but I just haven't got the energy to look at right now, is replacing the harness with a fuse file system. So you're not actually running RISC OS, you're just running the RISC OS file system things. And then you provide an alternative file core, and then you can share your file core images into your host system, just as if they were a regular disk. And that could be kind of cute. I mean, I realize that Linux has an ADFS file system. macOS, however, does not. So I would get the ability to access ADFS from macOS. Little things. I want to finish the sound system work because I've got a little way along that, but I've only done the 8-bit interface. I'd like to do the 16-bit interface. And more importantly, I'd like to do it in conjunction with the work that Jason's doing, so I can provide a testing system for that. Should there be another internet implementation that anybody does, I would like to match that up with the implementation that I've got.
We would also like that.
I've got some discussions to have on that with people, I think. I'd like to finish off some more of the PRM and XML work. That's another part. So that's not Pyromaniac specific, but it's all based around old style HTML. I'd like to stylify that. One of Jason's critiques of it immediately was, it's not the same font style as the PRM. You're quite right, it's not. And I can't easily change that because it's not stylable. That would be a nice thing to do. So those are a few things. I've got a bunch of other ideas, but a lot of it is I want to make something that's interesting for me. And if I feel comfortable about that enough, I will then try and make it out to other people. And that may come, it may take a while, but those are aims of it. The goal, as soon as it stops being fun and I feel I'm having to do things for people, actually having to do things for people rather than doing things for people because it's fun, that's when I have to be more cautious and call it a day on that. Which doesn't mean to say I won't do things for people if they say I'd like that. Because if it's fun, I'll do it. Oh, shucks. So Stuart said, when the fun stops, stop. Yes. Do you reckon threading might be workable? Now, threading is interesting. I don't know what the state of current RISC OS is. Current classic RISC OS, I mean.
Probably behind where you left it.
Well, the thing is, we could do interesting things. I've seen the write-up. I haven't actually seen the real thing, but I've seen the write-up for the BSD plus RISC OS system. That's an interesting thing, trying to work in a useful use of multiple cores. I suspect that RISC OS just doesn't offer a good way of doing it. Now, if people remember Niall Douglas's WIMP2 and its preemption model, it proved that you can do that in most cases. So it would be quite interesting to do that. I'm not sure that threading would be my first target. I would like to look at process isolation. So one of the areas I was looking at with Select was basically replacing A and B control plus change dynamic area, those two parts of the program environment, and potentially the VDU system, and bringing those together into a task management system. And that's task in the loosest sense, not WIMP task. That would allow you to have multiple processes that can be controlled and sub-processes that are not in the WIMP. In theory, that means you can then allow multi-threading because those applications, those tasks, are isolated and can have their environment changed underneath them and things. But it's a lot of work. And that's the other good thing about Pyromaniac. You can play with it. You can see what it can do. So those things will be quite interesting. Also, the WebSockets client that I created in Row Client, I had to rip out all the threading from that because we don't have any in RISC OS.
What do you think about the change in the WIMP and extract the entire multitasking infrastructure and memory allocation, or memory paging, I should say, from the WIMP and put it back into the RISC OS kernel?
I don't think that it's a thing that should be talked about at the moment. It should have been talked about 10 years ago. It's vital that all the WIMP should not be a manager of the system. It was a very, very clever solution, but that migration that started happening with A and B control being created should have been progressed, and we should have moved things out. Certainly, that was the purpose of the work in Select, to try and isolate tasks in that way. One of the advantages of that is that, yeah, I know. Sorry, Stuart's just said he talked about it for Arthur 1.7, but didn't have the time. Time is always the enemy for these things. I mean, that's one of the advantages of open source is that you can. Everybody's time is important, but you can get a lot more people involved in it, and you don't have that. You don't have that pressure of deadlines in quite the same way. So in theory, that could happen if you've got people who can architect it properly to make it move in the right way. One of the things I've said numerous times on forums in the dim past and relatively recently is that everything you look at inside task window should not be in task window. And if you can rip out all of the work that task window does, then essentially all of the work that the WIMP does has gone away as well. So you can look at it from both sides of the, am I making the WIMP work or am I making task window redundant? And people have done great things. I mean, Druck created GraphTask, I think it was, which was a similar implementation or hooks around it that did graphics from task windows.
It's very trivial. It's like not even worth mentioning in the context of stuff you're doing.
Well, impressed by it.
Make it more like that by
impressive to mere mortals, Druck.
By putting WIMP filters around it, so you can actually do things like draw and sprite APIs in it, but I never go around to it.
Yeah, so in Select there are certain things that task window does and that the kernel does to prevent those being a problem, but you again need a context that you're writing to. There is no context of a GC, to use other platforms terms, that are the things that you're writing to, and that's kind of what you want. That was kind of what I'm talking about by saying take the VDU system out, so that it also is part of that task context. There needs to be a decision architecturally about what the right solution is with that, whether it's we're following the Linux model of these are console-based things and they might have a graphics environment attached to them, but that's separate, or Windows where it's actually intrinsic with it. Actually, macOS is kind of similar as well in that regard. A task can have a GC and different environments within it as well.
Yes, we're all arguing about that at the moment on the Royal Forum.
It's complicated, I imagine. I'm trying not to. I'm not thinking on those things because they're interesting, but I could get bogged down in those things myself.
But I mean, what you've done is amazing. You say you've only been doing this for about the last 18 months or so?
Yeah, it's about 18 months.
I mean, how do you do it? I mean, you know, I've been porting little bits of RISC OS to other systems for about 20 years, and I've done nothing compared to what you have. I've just had 6 months where I've basically been on furlough. I've still done nothing.
So I suspect you have a family
I
or
do now.
friends. I don't have those things. So that's genuinely, that's another reason why I was unhappy, was because without groups of people and things, I mean, this is obviously before COVID, which has just made it worse. I was just not able to focus on things. So I come home or move away from the desk, as we do in lockdown now, and I have something to do. And like, okay, this is a thing I can play with, and that's just something that I can do. And if I don't feel that I've made enough progress on something, I switch to something else. Do
you ever get to eat and sleep?
Occasionally. That is another reason, another thing that I am working on improving. I haven't had my tea this evening. I was going to have it before this, but
Don't send that man a Deliveroo.
I got distracted, and then I had to go, and I decided before I do this talk, let me go and have a walk. So I chose to have a walk and be calm instead of having food. Yeah, but I can have food at any time. This is my opportunity to talk to people. I would love a cat as well. That would also be good. Cats can give you some love back. Code does not give you love back.
What saddens me is that RISC OS is a fairly small platform, but you felt that people were so impolite that they were being negative and horrible. That really makes me rather upset, that does.
Yes. So I'm definitely not going to go into anything about that, but after RISC OS, I had a breakdown. After having death threats and after having lots of legal things, I did not cope very well with the environment that we were in then. I was myself one of those people who was quite rude to people because I was so stressed and I was not coping. And I had to come away from that. I had to get away and do other things. And yes, that's sad. I don't think that I have let go of all of those things. I am better at some of those things. Are those people still around? I believe so. Do I want to interact with them? No, I don't. On the other hand, do I feel that I can talk to the community as I'm doing now? Kinda. This is progress for me. I'm feeling that I can do that. And some of the reason that I'm able to do that is because the community is different now. There may be some of these people here that I do not want to deal with, but that's not relevant. If there's a couple of people that I can't get on with, everybody has that. So I should not be running away from that environment. So that is why I'm trying to do this. As I may have said, I've had real difficulty to working up the courage to do this talk because I did not want to. I'm immediately thinking, what are people going to criticize me on? Have I done enough here? And that's the thing I'm trying to avoid by doing this whole project.
You've nothing to worry about. You've done brilliantly.
I was going to say, have you done enough? You've done about 100,000 times two.
I think the proper British way to say this, you've done above and beyond what we could ever expect. That talking for me, but I think also for many others. So thank you very much. Thank you very much for finding the courage, and please keep finding the courage because I hope there's going to be more talk from you. it was very interesting and very, very helpful.
To be fair, Gerph, you have Gerph rather. Well, 20 years of thinking it's pronounced Gerph.
Don't care. Any way you like.
Yeah. To be fair, when you're doing a talk to a group like this, you are talking to people who are actually interested in positive, rather than the people on the news groups and whatnot who are sometimes a bit more negative.
And that's better for me, and it's
Yeah.
better for all of us, I think.
Problem there, Jeff. You set the bar so high that if you try another talk, you'll be expecting miracles.
Honestly, I watched the talks that came before that were recorded, and I was like, oh my gosh, I've got to meet up to that standard. So I hope I've managed to meet the standard of other people. I hope I've managed to communicate things well. I'm sorry, as Andrew said, I may have skipped over some things. I don't take that as a criticism so much as you just didn't do the balance right. That's
I think
fine.
you've probably exceeded our expectations, to be honest.
Yeah. So just unless somebody's got any questions, I've got a question from Rob Speed here. Could sprites be implemented, do I think? Yes, I think so. I'm hoping that it'll just be a case of interfacing with the pillow libraries to make it talk to Cairo. I haven't tried it yet. I mean, I haven't even got Sprite V. Sprite V doesn't exist at the moment. And the only command that you can use that's related to that is star screen save that saves you a PNG. So probably, and it's going to be necessary, I suppose, if I'm going to do the WIMP. If anybody's looking at the Pyromaniac RISC OS online site, in the examples section, there's an example of the window manager, my version of the window manager, showing some loaded templates. Doesn't do anything with them. It's literally just the windows you create. But any part of the WIMP will need sprites. Yeah. Any other questions?
I have a questions that only if there are no other questions, because it's going to be a bit more, developers very much related. So only if there are no other questions. I would like to ask how context switching works into Pyromaniac infrastructure.
Context switching, do you mean context switching as in WIMP style?
No, mostly when some module try to have high privilege and move to user space to supervisor.
Right. So largely that takes place inside Unicorn itself. So I don't have to care about it. But there are dedicated switching points for moving yourself between SVC and user mode. One of them is by just changing mode and then triggering a SWI, so you get interrupts triggered. And that's usually the way that, for example, readline or readc make sure that the system keeps working whilst you're actually threaded. That kind of works, but it's a bit of a mess. Internally, I don't spot if you just switch to user mode and then switch out again. So using that mechanism to do things doesn't work for triggering interrupts and the like. The other thing is in select, there is a dedicated entry point that is intended for, I am now starting a new application, which is, I believe, the correct way to do it. In Classic before that, and I do not know about RISC OS 5 because I just can't speak to those interfaces, the mechanism you used for those sorts of context switches was flatten the SVC stack and then switch to user mode. The downside is that you're basically putting all control on the application. And the goals with this particular interface that I was creating and the move to applications in a different managed way was the application should not be in control of the system, because the application being in control of the system is what causes the system to be irrecoverable when something goes wrong. So moving the model around so that the kernel, the operating system, is in control and you are a client of it will allow yourself better better management of the system. And personally, I think that that sort of model leads itself into multi-threading, it leads itself into multi-process, and yeah, there's a lot of other good things you can do with that. So I'm not sure if that answers your question, but
it does. Thank you very much. No, I understand. I can have the details straight from Unicorn. One interesting thing out of your work that may come out, and this is going to open a lot probably of discussion, but it is the way you actually visit some of the API intercept and this type of things that could actually be potentially good for a passage to 64-bit for the operating system, because we know that even if we recompile or even if we execute BBC Basic application in 64-bit, they may expect still a 32-bit like API, which has to be somehow simulated in 64-bit. Where simulated doesn't mean interpreted, but it means that it has to react in a 32-bit fashion, rounding numbers that go above certain thresholds and things like that. So you're actually opening a very, very interesting path forward here, because the biggest problem with the 64-bit, as actually Stuart pointed out on the forum, we can actually bring it straight forward into 64-bit by translating the assembly. But the problem is that that thing that will come out will not behave as people will expect it to do. And so there is a need for what you're doing actually.
So I have some ideas on that. And again, I haven't thought about it huge amounts because I'm not really caring so much. But my thoughts is look at how 64-bit, 32-bit works on macOS. So they've just dropped that in two revisions of macOS ago. And one of the ways they got around that was they translate the OS APIs so that you have the same OS APIs, but just with different memory space. And if you can do that, so you essentially have a restricted space view of things, I think that might be able to work. Essentially, you're doing an emulor. And emulor is an incredible achievement, but I think you should be able to use the same technology, same mechanism of doing that. Now, ARC64 is a little different, but mostly the instructions have analogs. Not quite all of them, and the flag model is a bit different, and the exception model is completely different. But I think that can work by translation for a lot of things. It gives you some of the things, but you're kind of working to a different environment. One of the things that's interesting about Unicorn is that if I wanted to, I can start the system in ARC64. If I just give it a different set of parameters, the system will be executing that kind of code. So yeah, that certainly could be tried out. And if people want to try that out, the same could happen. I was actually kind of interested in trying out Thumb and seeing how well Thumb works, but it seems like, well, RISC OS just doesn't embrace Thumb, which is a bit weird, really, but given that it's used everywhere else. But that would be a genuinely interesting thing to do. One of the other things that's interesting about the 64-bit stuff is that you should be able to think about reworking some of the APIs. So just have them as new implementations. Whether you want to keep an ARC64 system being a souped-up BBC-B, I don't know.
I am totally with you on that, but the reality is this: that if people want, for example, to recompile C application on 64-bit, you know what this means. There must be some emulation of the old 32-bit API. Otherwise, there will be unexpected behaviors.
Yeah, I mean, there's always the point that you could take the Linux It's not called capabilities. Personality. So Linux has, or was it BSD? One of the Unixes had a concept of personalities, which was, this is what sort of operating system it is. And once you change personality, your system call interface completely changes, your memory map changes, and it's still handled by the system in a same sort of way, but you go through a translation for that. Maybe that's one of the ways that could be done.
Yeah, yeah. By the way, that was BSD.
It was BSD, was it? I couldn't remember which.
No, yeah, it's a great proposition, actually. I really like the idea. I think it's a good idea. I'm just trying to figure out how to do it on RISC OS.
Yeah, I mean, like anything, those sorts of problems they're not something you're going to fix or solve overnight unless you have a really good session in the shower where these things just come to you. I mean, in the shower is where ideas tend to come to me anyway. Just whilst I was just reading, somebody asked a question about why Python rather than anything else. So Python is my day job. Well, one part of my day job. It's highly structured. It gives me a lot of flexibility, and it's an object-oriented language. I did not feel that C would be a good language for this. I feel similarly about writing C code to writing ARM code, actually. It's a lot of faffing around, and I don't necessarily get the benefit from it. Whereas Python, it's a lot quicker to just try something out and see what things happen. And it has a lot of structures. I am admittedly using Python 2.7 at the moment. And the reason for that is because Python 3 saw a 20% speed reduction when I tried porting it. And that was quite a bit more painful. So I didn't get around to doing that. I will port it to Python 3 now that 2.7's end of life. But that was the main reason for Python. And Paul had asked a question about Rust, what I think of it. I don't know a lot about it. I know that a few people have spent time working on it from RISC OS world, but I just don't know a whole lot about it, I'm afraid. Sorry, I don't have enough to give an opinion.
I'd like to congratulate you on using Python, because I got into Python and learned a bit of it and used it for the odd bits. But now I work for a company that does a whole video conferencing system in Python. They use it as the main development language. It's running on all the servers, running in the cloud, and they can do wonders with it. And it really shows you what it's capable of. So, and I'm learning new things about it all the time now.
I still am. We've just gone through a Python 3 transition at work, and even now I'm still learning things about 2.7 and about 3. They just keep coming up, and I disagree with some of the things that have happened in 3, but it's so much more powerful. I mean, it's one of the things with Pyromaniac is I have focused on getting something that's functionally able to be debugged and to be able to be implemented well. And performance is not a concern for me. Now it is a concern, but it's not a huge concern. So when I think, oh yes, I've just got this SWI call that's come in, it's gone through 15 functions to get to where I am, some of which were going through object lookups and like that. It makes me terrified from the ARM side, but on the other hand, it's like, I don't care. I mean, I will give a small anecdote though. So just before, that's who you work for, is it?
Yeah, that's who I work for now. Yeah.
Okay. I thought you worked for a race car company.
I work for McLaren, but you know, COVID happened. So
I'm very sorry to hear that, but glad you've got something.
It's been a good move for me so far.
So Rob asked about getting a copy of the slides. The slides are on the Pyromaniac site under the slides link. You can download them both as zip archive of PNGs, and they are scrollable in the browser. Sorry, I was giving an example. So just before I was releasing the Build RISC OS online site, I went and I just got it uploaded, and I went and ran the test and went, why is it running like badly? So it was one of the simple hello module example that I'd got on there that builds a C module with cmunge and then links it, took about a minute and a half to compile and run. And I was like, this ran through in about 6 seconds max. What have I done? And what had happened was I had off synchronized code areas was taking 2.2 seconds every time you called it. Now, it's documented as a slow call, but that's not what people expect. When I added in trace points are, you can tell it, I want to track this function, but it doesn't know where the functions are. So every time memory changes, it goes and looks up, all of the memory and checks whether there are function signatures in there. And it does that on synchronized code areas because at that point, you know memory has changed. When I had a 15 megabyte WIMP slot, extracting that data in Python and parsing it and everything was an involved process. And I had made it shit. I've now fixed it so that A, the memory access is faster, and B, we only actually scan the memory when you've got trace points present. But those sorts of things, not caring about performance can actually be a pretty significant issue. So there are two sides to the using Python. You've got to be sensible in what you're actually doing.
Well, I think I'll just add my thanks then. I've been keeping quiet while letting people ask the questions. But the chat has been mostly full of people saying how amazing that talk was. So thank you very much for coming along.
I was just going to say, referencing your earlier comments about state of mind, I remember when I was a teacher, we had Ofsted. The amount of swearing in the staff room went up exponentially as the Ofsted loomed. And when you couldn't produce worksheets with something wrong, the number of people who kicked the photocopier in the hopes that it would perform better. And the other thing is, have a word with Andrew, because he makes a wonderful mug that they produce. It says, keep calm and enjoy RISC OS. Holds tea, coffee, beer, and any other related liquids. Send him one, Andrew.
Yes, it sounds good to me.
Well, I guess we can now any kind of general chat we can descend into now. I guess.